Hello students, now today we will discuss node analysis. In previous class already I told you Maxwell's loop analysis and how to apply Kirchhoff's voltage law in Maxwell's loop analysis. In what we have solved in Maxwell's loop analysis, that is your resistance matrix into current matrix equal to voltage matrix. If the question asked to find out the loop current I1, I2, I3, first of all how will you calculate I1, I2, I3 using Kirchhoff's voltage law? First of all, you have to select, that is your to convert the current source into voltage source, then resistance matrix, current matrix equal to your voltage matrix, then find out the loop current I1, I2, I3. But in case of node analysis, so this is slightly better than your Maxwell's loop analysis. Our computation is much faster than Maxwell's loop analysis if you follow the node analysis. But thing is, in node analysis, we have to convert a voltage source into current source. In previous case, in Maxwell's loop analysis, first of all, we have to convert current source into voltage source. But in case of node analysis, we have to convert voltage source into current source. In there, we have applied Kirchhoff's voltage law. But in case of node analysis, we have to apply Kirchhoff's current law. So in node analysis, here, that is your node analysis, I have selected two nodes. This is your node 1 and this is your node 2. In case of Maxwell's loop analysis, that is your resistance matrix into current matrix equal to voltage matrix, then we will find out the I1, I2, I3 by help of the Cramer's rule. But in case of node analysis, we have to convert resistance into conductance. Already I told you, in a resistance means what? The conductance, reciprocal of resistance is your conductance, G. If there is a resistance, you have to convert it into conductance. So reciprocal of resistance is your conductance. Reciprocal of Y is your admittance. Reciprocal of impedance is nothing but your admittance. And reciprocal of reactance is nothing but your suspectance. Okay. In case of node analysis, we have to convert resistance into conductance. If there is a resistor, so G1, here G1, G is nothing but 1 by R. That is here, this is nothing but, if you convert resistance, 1 by R1 equal to G1, 1 by R2 equal to G2 and 1 by R3 equal to G3. First of all, in node analysis, we have to convert a planar network. Planar network means what? So here there are two nodes and here this is a reference node or datum node. Here grounded, this is 0 volt. This is nothing but a 0 volt. So this is a reference node or datum node. And here there are two nodes, node 1 and node 2. So in a basic things, so first how you apply the current? In case of loop analysis, simply voltage equal to current in resistance. When you are going to calculate the current, suppose there is a resistance here and there is a potential V1 and there is a potential V2. Suppose the resistance is R. How much current flow through this resistance? I is nothing but what? V1 minus V2 by R. So here I equal to how much? That is your difference potential V1 minus V2 divided by R. This is nothing but your V1 I. Similarly, when you are going to calculate current, if there is a two potential, so that is your current is nothing but difference between the two potential divided by the resistance here. So first of all, now we are going to analysis how a generalized formula like your Maxwell's loop analysis, that your resistance matrix into current matrix equal to voltage matrix, by using Cramer's rule we will find out I1, I2, I3. Similarly, in case of node analysis, so first of all we have to derive an expression so that in loop analysis resistance matrix into current matrix equal to your voltage matrix, but here that is your conductance, resistance converted into the conductance, G into V equal to I, that is your conductance into voltage equal to I. So G is nothing but 1 by R, G is nothing but conductance, G is the reciprocal of resistance, so 1 by R into V by R equal to I. So in node analysis, that is your what? One is your conductance into voltage equal to current. Okay. Now, first of all, in this network, there are two nodes. I am considering here the node 1, that is your V1, and a node 2, that is your V2. Suppose if I am going to calculate this one, the current, what is the current flow through this one? That is your what? Ia equal to, this is nothing but I1. This is nothing but your I1. This is nothing but your I1, and this is your current here, and here IB equal to, this is your IA, and this is your I1, and this is your let I2, and this is your I3. This is your I3. Okay. So applying Kirchhoff's current law at this point, if you are applying Kirchhoff's current law at this point, IA equal what? I1 plus I2. IA equal to this current, if you are applying Kirchhoff's current law at this point, IA equal to I1 plus I2. Similarly, IB equal to, that is your I2, this is your incoming current, and this is your outgoing. This is your incoming, this is your incoming, this is your incoming. Okay. So this is nothing but, that is your, apply Kirchhoff's current law at this point. Apply Kirchhoff's current law at node 1. At node 1. Okay. If you are applying Kirchhoff's current law at this point, this current, incoming current, and this is your outgoing current, IA equal to I1 plus I2. So IA equal to, this current equal to I1 plus I2. IA equal to I1 plus I2. So here I1 is how much? This current. So that is your V1. This is your, this difference potential, this is this one. So in G1 is nothing but what? 1 by R1. 1 by R1. So this is nothing but what? That is your V1 minus V2 by R. I can write this R, I have converted the conductance G1, R1 here. So I1 is nothing but what? I1, in place of I1, you can write V1 minus 0. V1 minus 0, this potential is 0. So V1 minus 0 by R1 plus I2. This current is how much? This potential difference between these two potential, V1 minus V2 divided by R2, plus V1 minus V2 divided by R2, or which equal to V1 into 1 by R1 is nothing but G1. I can write directly, I can write V1 into V1 by R1, 1 by R1 equal to G1. That is your G1. Similarly, that is your what? V1 minus V2 by R2. V1 by R2 minus V2 by R2. V1 by R2, V1 by R2 is this value. This is nothing but your G2. This is nothing but your G2. G2 into V1 minus V2 by R2. V2 by R2 is nothing but what? V1, I can write V1 minus V2 whole into what? G2. This is your 1 by R2. 1 by R2 is your G2. That is your G2 into V1 minus V2. So here you can write this current IA equal to, that is your V1 G1 plus G2 into V1 minus G2 into V2. So that is what? That is your I can write, if taking common V1, that is your G1 plus G2, G1 plus G2 minus, that is your V2 into G2. This is nothing but this current IA. So this is your, this current, this is the expression of the node 1. Okay. So here, then considering the node 2, consider the node 2, consider node 2, consider node 2. Here this is your I2, this is your IB, I2 plus IB, this is nothing but what? Let this is outgoing current. If you considering this point, I2 this is your incoming current, IB is your incoming current, but I3 is your outgoing current. This is your incoming current, this is your incoming current, and this is your outgoing current. I2 is your incoming. If you considering the node 2, I2 is incoming, IB is incoming, I3 is your outgoing. So incoming current equal to outgoing current. If you considering node 2, apply KCL, apply Kirchhoff's current law at node 2. If you applying Kirchhoff's current law at node 2, incoming current equal to outgoing current. So incoming current I2 plus IB equal to I3. I2 plus IB equal to I3. I2 plus IB equal to I3. So IB equal to how much? IB equal to I3 minus I2. IB equal to I3 minus I2. The I3 value is how much? This current. Ultimately, in place of current, you can write the voltage into conductance. This is your I3. I3 value is nothing but V2 into G3. Or otherwise, you may write this is nothing R3. How to get a G3? Because 1 by R3. This is nothing but this is your R3. This is the resistance R3. 1 by R3 is your G3. 1 by R3 equal to G3. So this is your conductance. So how to get I3? I3 equal to V2 into G3. IB is how much? IB equal to this I3. In place of I3, you can write that is your I3 V2 into G3. V2 into G3. Then I2, the value of I2. I2 is nothing but what? The difference voltage what? V1 minus V2. This is your G2. I2 equal to, in place of I2, you have to put voltage into conductance. I2 is how much? V1, the difference potential is your V1 minus V2 into G2. So V2 G3 minus, that is your V1 minus V2 whole into, that is your G2. Are you clear or not? So first of all, if you apply Kirchhoff's current law at this point, this is your incoming current, this is your incoming current, and this is your outgoing current. So incoming current equal to outgoing current. Incoming current is your I2 and IB. So I2 plus IB both are incoming current, and I3 is your outgoing current. And IB is how much? I3 minus I2. In place of I3, current equal to voltage into conductance. I3 value is how much? I3, the potential at this point and this point, this is a reference node. I3, V2 minus 0, that is your V2. That is your V2, the conductance, minus, then I2 value is here is I2. The current difference potential is your V1 minus V2 into conductance, that is your G2. So V1 minus V2 into G2. Then IB is how much? IB equal to, so this is your V2 G3. I can write V2 G3 minus V1 G2 plus V2 G2, or IB equal to, first of all, considering first term V1 G1, the term containing V1, first of all we have to write the term containing V1. This is your minus V1 G2. So that is your, you can write minus V1 G2. Then the term containing V2, this term and this term, if you taking common V2, that is your G2 plus G3. So then plus V2 whole into G2 plus G3. Okay. So this is your, this expression is nothing but the equation at node 2. If you considering the node 1, we have got IA equal to V1 into G1 plus G2 minus V2 G2. If you considering the node 2, similarly apply Kirchhoff's current law, incoming current equal to outgoing current, and that expression will be IB equal to minus V1 G2 plus V2 into G1 plus G3. So then if you will generalize these two equations, let this is your equation 1 and let this is your equation 2. So in matrix form, what we will do first here? So this is your IA and this is your IB. Current matrix is nothing but what? Voltage into conductance equal to current. like in case of Maxwell's loop analysis, resistance into current equal to voltage, resistance matrix into current matrix equal to your voltage matrix. Similarly here, if you consider that is your here using equation 1 and 2, using equation 1 and 2, equation 1 and 2, this is your current IA, this is your IB, this current equal to, this is your voltage, in place of voltage that is your G1 plus G2, G1 plus G2, and here that is your minus G2, this is your conductance. Then considering equation 2, IB equal to minus V1 G2, that is your conductance is your minus G2. Then this is your G2 plus G3, conductance is your G2 plus G3. This is your conductance matrix into, that is your voltage, that is your V1 and V2. Okay, this is very important. This is very important. Already I told you in Maxwell's loop analysis, that is your resistance into current equal to voltage. Similarly in case of node analysis, conductance into voltage, G into V equal to I. So unknown value is your voltage V1 and V2. In case of loop analysis, we have to find out the loop current I1 and I2. But in case of node analysis, we have to find out the node voltage V1 and V2. If you observe, this is your matrix form. If you considering 1 and 2, look at this first here, G1 plus G2 into V1, G1 plus G2 into V1 minus G2 V2 minus G2 V2. This is nothing but your IA, this is nothing but your IA. Similarly, equation 2, look at this, that is your minus G2 into V1 minus G2 into V1, then plus G2 plus G3 into V2, G2 plus G3 into V2. So that means if these two equations, if you rearrange these two equations, you will get this matrix form. So what do we observe? When we are going to follow the node analysis, we have to find out the node voltage V1 and V2. Here we are going to calculate the node voltage V1 and V2, and this method is very much faster than your loop analysis, Maxwell's loop analysis. Here only you will get the 2 into 2 matrix, conductance matrix into voltage matrix, that is your IA and equal to current matrix. So in case of node analysis, the procedure is what? Remember, what is the procedure? First of all, consider a planar network. Consider a planar network. Second step, choose a reference node or datum node. This is your reference node or datum node. Then find out the conductance matrix into voltage matrix equal to current matrix. Then another thing is, important thing is, if there is a voltage source, immediately you have to convert to the current source. 3 points you should remember. Consider a planar network. Secondly, choose a reference node or datum node. Third point is, if there is a voltage source, you can convert it into the current source. So after step 3, then you apply the conductance into voltage equal to current. After that, you have to find out the two unknown values, the node voltage. If there is your 2 into 2, that is your node voltage V1 and V2. Once you get V1 and V2, you can easily calculate all the parameters of a network. So here, in case of node analysis, observe, here this is your node 1, considering this is your node 1, it is very important. Like this is your G11, G12, this is your G21 and this is your G22. Like is your resistance into current equal to voltage. In case of loop analysis, in there sum of the resistance formed by the loop 1, R11, R12, R13. 11 means in the loop 1, 12 means loop 2, 13 means loop 3. If it is a 3 into 3 network. But in case of node analysis, that is your, if you considering the node, the respective part conductance, this is your conductance, how many conductance are connected this node 1, how many conductance are connected in the node 2, if there is another node 3, how many conductance are connected in the node 3. If you observe, since it has two nodes, that is nothing but 2 into 2 conductance matrix. In the 2 into 2 conductance matrix, the sum of the conductance formed by the node 1, that is nothing but your G11. G11 is nothing but here sum of the conductance formed by the node 1. If you considering here node 1, how many, this one and this one, this one, 3 branches, this is node. So how many conductance here connected to node 1? 1 and 2. So sum of the conductance formed at the node 1, that is your G1 and G2, G1 plus G2. Similarly, G11, G12, the conductance common between node 1 and node 2. This is your node 1 and this is your node 2, and this is a common. If this is common, put the minus sign, minus G2. Similarly, G11, G12, then G21, 21, 1 to same, 1, 2, 2, 1, same, that G2 is common, that's why I put the minus sign, minus G2. Then G22, G22 means what? Sum of the conductance formed at the node 2. How many conductance formed at the node 2? This is your G2, this is your G3. G2 is nothing but 1 by R2 and G3 is nothing but 1 by R3. So G2 plus G3, this is your G2 plus G3. Then V1, V2. So using Cramer's rule, the unknown parameters V1, V2, we can calculate it. Are you getting or not? Again, I am repeating again. If in a node analysis, first of all, you consider a planar network, then choose the datum node or reference node. Then if there is a voltage source converted into the current source, then apply the node analysis, conductance into voltage equal to current, conductance into voltage equal to current. The unknown value is your V1 and V2, the node voltage. When there is a 2 node, there will be 2 into 2 matrix. In a 2 into 2 matrix, G11, G12, G21, G22. So G11 is nothing but what? Sum of the conductance formed by the node 1. How many resistance or conductance connected at the node 1? The reciprocal resistance, simply if there is a resistor, you reciprocate it. If there is R1, previously it was R1, I have converted G1 because 1 by R1 equal to G1. Previously was R2, I have converted 1 by R2 equal to G2. So that's why G11 is nothing but sum of the conductance at the node 1, G1 plus G2. Similarly, G12, conductance common between 1 and 2. So node 1 and node 2 common is G2, so minus G2. G21 is same, that is your minus G2. Then G22 means sum of the conductance at the node 2. At node 2, how many number of conductance? G2, G3, that's why G2 plus G3. After forming the matrix, then you can find out the unknown voltage V1 and V2. Okay, so now I am considering a problem. Here in this problem, calculate the voltage across AB using node analysis. So here calculate the voltage across the AB. This is your A and this is your B. Okay. So in this network, if you considering the Maxwell's loop analysis, remember it will be what? 2 loop. So resistance into current equal to voltage. Then 2 loop currents I1, I2. Then R1, R1 to R2, R2 to I1, I2. Then V1 net voltage V1 and V2. In there you have to calculate the loop current I1 and I2. But in here, in case of node analysis, it is much faster than your previous one, loop analysis. Here I am redrawing the circuit. This is your A, this is your B, this is your A, this is your B, A to B, there is a voltage source and there is a resistance. If there is a voltage source, I will convert it into the current source. Already I told you, in case of node analysis, is there any voltage source, immediately you can convert it into the current source. This is your minus terminal and this is your plus terminal. Already I told you, if there is a voltage source, direction from the voltage source minus to plus is plus. The direction is like this. Similarly here, this is a minus terminal and this is your plus terminal. The direction of current is like this. So this is your AB. I am redrawing the circuit A to B. There is a voltage source 12 volt and 100 ohm, and here there is 6 volt and 20 ohm. 6 volt and 20 ohm. Again, I will convert it into the node analysis. In case of node analysis, this is nothing but your what? 0 volt datum node or reference node. In this, I am converting the voltage source into current source. That is your current. How to calculate the current? V by I equal to V by R. 12 by 100, that is your 0.12 ampere. then resistance will be parallel. Here 100 ohm will be parallel. I am converted, that is your G1, 1 by 100 is nothing but 0.01 mho. Reciprocal of resistance is conductance. Reciprocal of impedance is admittance. Reciprocal of reactance is susceptance. So immediately you converted 1 by 100, that is your 0.01 mho. Similarly here 10 I am converting here what? That is your conductance 1 by 10, that will be equal to 0.1 mho. Similarly here there is a voltage source, you can convert it into the current source. 6 by 25 is nothing but 0.24 ampere. Then 25 ohm, 1 by 25, that is your what? It is nothing but 0.04. Okay, so that is your mho. Then this is nothing but A and this is nothing but your B, 10 ohm. Okay, then apply node analysis, that is your conductance into voltage equal to current. The conductance matrix into voltage matrix equal to your current matrix. You will found only one node. Okay, so this 2 into 2 network can be converted into a single node if you will follow the node analysis. So conductance into voltage equal to current. How many conductance? This is your what? This is your higher potential and this is your lower potential. How many conductance? That is nothing but 1 by 100 plus 1 by 10 plus 1 by 25. So this is nothing but conductance is your what? 0.01 plus 0.1 plus 0.04. This is your sum of the conductance here into voltage, the unknown value. We are going to calculate voltage equal to current. Tell me what is the current? This is the outgoing current and this is your incoming current. Incoming current equal to outgoing current. So that is your current is nothing but what? 0.24 minus 0.24 minus 0.12, because incoming this is plus and this will be minus. That's why 0.24 minus 0.12, that is your 0.12. So then if you add this 0.01 and like this, the value will be how much? So using calculator, that is your 0.01 plus 0.1 plus 0.04. The value is how much? 0.15. So 0.15 volt equal to 0.12. Okay, so then you can find out the voltage. V value is how much? The voltage equal to 0.12 divided by 0.15. The value will be how much? 0.12 divided by 0.15. The value is your 0.8, that is your 0.8 volt. So the question asked, find out the voltage across AB. The voltage across AB is how much? 0.8 volt. So thank you. So next class we'll do more and more number of problems.